All right, to the best of your ability, I want you to do it first, then watch the video. Okay? Here we go. Write this down, and then look at number 1. Can you integrate from 0 to 2 f of x dx? You going to try it first? All right, you've tried it, right? Here we go. So the hook, so first of all, when you integrate, what is the hook? So if I did this on the side, the hook for this is 2, so what it was over what it becomes, and the hook is not part of the answer. So 1/2 is. So it's 1/2 e to the 2x. Integrate 2x. That's 2x squared divided by 2, which is really just x squared, and then 1 is 1x. And then not c, it integrates from 0 to 2. Then you plug in, and you don't have to simplify. You plug in 2, subtract, and you plug in 0. Really, e to the 0, I'm just left with 1, and there's your answer. So e to the 0 is 1, and 1/2 times 1 is 1/2. So it's the top bound, subtract the bottom bound. Number 2, you need to do it first. Find the area enclosed by those graphs. So again, I'm going to integrate, and I actually already did the work, top, subtract, bottom. If you want a sense of the graph from 0 to 2, I know that when I plug in 0, the answer is 1 plus 1, which is 2. This is also an increasing function. So whatever it is for 1 and 2, all I really care about is top, subtract, bottom. So when I do that, I'm integrating from 0 to 2, top, subtract, bottom, which is this. And then what's the answer? I just came up with it. So that is the answer for the area. Number 3, what is average value? That means you integrate. Now, we already did the integration. So it's the integration from 0 to 2, and then you subtract the difference of the bounds. So it's that answer, 1/2 e to the 4 plus 2, take away 1/2. That answer divided by 2. That's the average value. So it's an integration question, and then you divide by the difference of the bounds. That's it. Number 4. The volume formed by revolving the region around the x-axis. So when I think of this region that I kind of graphed, right, that curve here, there is no space there. So if I revolve around it, it's one circle. So that's pi r squared. And that's it. That is going to give me the volume revolving around it. And then you'd use your calculator and you would do it. So with your calculator, this is pi, and then integrate. So menu calculus integrate. And we're going to integrate from 0 to 2, and then you would type it in. So that's e to the 2x plus 2x plus 1, and that's it. Oh, and then square that. Oops, I didn't start with parentheses. Let me start with parentheses, because then I got to square it. Now it'll allow me to square it. And then dx. There it is, pi r squared, and the volume is 3,091.480. Number 5, find it by the volume of solid generated using semicircles. So the area of a semicircle is pi r squared divided by 2. If I go top, subtract bottom of that region, that's actually the diameter. So if I want to find the radius, I go top, subtract bottom, divided by 2, and that's what I do. So I'm going to integrate from 0 to 2. The formula is pi r squared divided by 2. There it is, pi r squared divided by 2. Then what goes in for the radius is this. So let me just see it. It's top, subtract bottom, divided by 2. So how would that look like in here? I go parentheses, and then what am I typing in? Type in that. E to the 2x plus 2x plus 1. I'm going to put parentheses around that and divide by 2. So put parentheses around that, divide by 2, and then square it. And then that answer is divided by 2. I get 386.435. Number 6. Set up an integral for the volume revolving the region about the line y equals negative 2. So if I think of this region around y equals negative 2 down here, now when I revolve around, there's a space. So I have 2 circles. So we're going to go from 0 to 2, and we have a big radius, and we have a small radius. Now for the big radius, I'm going to go top, subtract to the bottom. So the very top here, top, subtract bottom is f at x, subtract negative 2. And when you subtract a negative, it's really adding. So when you subtract negative 2, it's plus 2. And then the small radius is right here, the bottom of the area to here. So it's really 0, subtract negative 2, or just 2 is the small radius. And then you would type that in. Oh, it just says set it up. So I'm just going to set it up. There's the setup to find it. Number 7, subintegral to find it with rectangular cross sections perpendicular to the x-axis. So a rectangle, the formula is base times height. So when I plug it in from 0 to 2, I need to know the base of it. That's top subtract bottom, which is e to the 2x. It's just f at x, let's say. And that times the height. And it says the height is half the base. So if the base is f at x, then it's the base times the height, and the height is half the base. You could also put it together as 1/2 f at x squared. Not necessary. But I think you understand it better looking at it this way. The base times half the base. There it is for the rectangle. Number 8. Find the derivative of f at x. Let me write this down again so we can do that. E to the 2x plus 2x plus 1. So if I took the derivative, and again, you should press pause and do it first. You copy and the hook plus 2. Done. Good job, right? You did it first, and you did it right. Number 9. Find the tangent and normals. So let's talk about that. So first of all, let's figure out our x or y. So if our x is 0, and if we plug in 0 for x, I think we already did this, you get 2. So e to the 0 is 1. That's 0 and 1. So it's 1 plus 1. So that's why it's 2. And then we use the slope. And again, we plug in 0 to the slope. So e to the 0 is 1. So it's really 2 plus 2, which is 4. So tangent would be 4. X minus 0 plus 2. Yep, you don't need minus 0. The normal is the negative reciprocal. So negative reciprocal, and everything else would stay the same. So this one is tangent. This one is normal. All right, number 10. Find an equation of line tangent to the inverse of f at x equals 2. So at x equals 2, if I look back here, inverse means these are flops. So if x is 2, now y is 0. So it means like inverse these numbers, 0 and 2. So now these are the numbers because you've inversed it. And the relationship between their slopes is the reciprocal. So whatever the answer, not the negative reciprocal, that's perpendicular. Then change the sign. We're not changing the sign. Just the reciprocal is the relationship between inverse functions. So when I think of calculus and inverse, it's reciprocal of the derivative. So it's just 1/4. So it would be y equals 1/4 x minus 2 plus 0, but I don't need a plus 0. Number 11. Use your calculator to find the value of C which satisfies the mean value theorem. That is A rock equals I rock from 0 to 2. So A rock is y2 minus y1 over 2 minus 1. The IROC is the derivative which we said was, what did we just say the derivative? I just had it. 2e to the 2x plus 2. So when I plug this in, I'm going to use my calculator. So the easiest way I think to plug this in is to go to the graph, go to tab, and redefine this one. So I have something there for f2. Now I don't. And f1, see f1 at x. I'm going to actually type in e to the 2x. What's the next part here? Plus 2x plus 1. So this is what the graph looked like, which I didn't do. So you can see it curved up more than I think, but it didn't really matter how far it curved up. But anyways, it's defined now in my calculator. So when I do y2, so I'm going to go menu algebra solve. And then I'm going to have a fraction. And then on top of the fraction is going to be f1 at 2 subtract f1 at 0, right? That's the AROC, over 2 minus 1, or just 1. We can type in so you can really see it. Equals, and then the derivative, which is 2 to the EX plus 2. And then, oops, so 2 e to the 2x plus 2. Make sure that you move the cursor over, comma x, control enter, and the answer is 1.66. So that is the C value. And notice the C value is in between 0 and 2. At that one, the average rate of change equals the instantaneous rate of change. Number 12. Find, this is a different equation. So number 12, you have a position 5 subtract t plus ln t from 1 over e to e. And you're asked, find first the position at e. So it's 5 subtract e. And then ln e is just 1. So this answer would actually just be 6 subtract e. It's good to know how to simplify it. V at e means I need to find the derivative. Oh, I need to do that first anyways. Sorry, I was doing 14 here. So 12 is find the velocity first. So 5 is 0, that's negative 1, and that's plus 1 over t. And then the acceleration, that's 13. So the derivative of negative 1 is 0. 1 over t is t to the negative 1, so the derivative of that is negative t to the negative 2, or negative 1 over t squared. Then, when we're asked these other questions, like xe, what's the velocity at e? Plug in, and it's negative 1 plus 1 over e. If I say, hey, what's the acceleration at e? What number are we at now? 15, 16. The acceleration at e would be negative 1 over e squared. If I said x, this is number 17, x at 1 over e. Go back to the beginning, so it's 5 minus 1 over e. Now, 1 over e is e to the negative 1. Just recognize this. 1 over e is e to the negative 1. This negative 1 can go in front, so it's really just ln e is 1. So it's really negative 1 is the answer. These cross out. So this is 4 minus 1 over e. Number 18, the velocity at 2 would be negative 1 plus a half. That's negative a half. 19, the acceleration at 2 would be negative 1 over a quarter. Plug it in 2 for t. All right, when, going to run out of space here, 20, when is the particle at rest? That's when the velocity is equal to 0. So to solve this, add 1 to the other side. Cross multiply, and you can see it's when t equals 0. 1, that it's at rest. Because if you plug in 1, it answers 0. Anyways, draw a number line for 1. And it goes from 1 over e to e. which is like the fraction 1/2 to 2, kind of. 2.7, right? 1 over 2.7 to 2.7. Anyways, plug in like 2/3 or something into the velocity, and you recognize it's going to be a positive answer, because when you plug in 2/3, the reciprocal -1 plus 3 over 2, it's going to. But if you do the other way, like if I plug in 2, the answer is going to be negative. So what that tells me, it's moving right. It's moving to the right from 1 over e to 1, and it's moving to the left from 1 to e, right? Positive and negative. We're almost there. Find the total distance. So I'm going to set this up for you. The bell's going to ring soon. Total distance is the absolute value of velocity. So we're going to go from 1 over e to e. So with your calculator, you would plug in 1 over e to e. You can do it without me, so I'm not going to do it. You're going to do it. So the velocity was -1 plus 1 over t. You do it. I'm going to check your work to make sure. Did you type that in and get the answer? You can use Desmos if you want, but I'm going to check to see if you did that. Make sure you use the absolute value to do that. And if it says show an integral setup to find the and find the same total distance without using your calculator. Huh. Well, without using my calculator, in terms of it, when I look at 1 minus, I don't even know what just use your calculator. This will be 21 and 22. Just use your calculator. I'm trying to think in terms of what they're thinking. If you think of the graph in terms of it, in terms of where the velocity, in terms of being negative and so on, I'm thinking through. Anyways, use a calculator. There we go. I'll think through how you would do it without a calculator in a moment or not. Mr. G Math over and out. Hey, I am proud of you for doing your work even during spring break. And I'm glad that you did your work first and then checked your work. And I hope that you feel like you're getting stronger in calculus. Till next time.